Okay, welcome back to again Ram Circuit class. We have a very simple numerical today that we are going to discuss, that is a wire of resistance 10 ohm is stressed to thrice of its original length. What will be its new resistance and what will be the new resistivity? So better we go to part number 2. You know that resistivity does not depend on its length or thickness or whatever, that is physical dimension. So the answer of second part is that the rho does not change, it remains same. Okay, that is clear, because rho depends only on what? The number of electrons. In the last video we had discussed, that is rho is equal to m n e square and tau. So if I increase the length or decrease the length or decrease or increase the thickness of the wire, then no area of cross section or no length is over here. So obviously the rho is independent from L, length of the conductor, and area of the cross section. Okay, this is clear hopefully. Now going into the first part. The question is that the wire, suppose this is a wire, its length is now L, and if the area of cross section is A, and this is further, but it is increased to thrice of its length. Now very important thing to notice over here, the wire is stressed to thrice of its original length. It means if it was L, the conductor on stretching becomes thin and its length becomes thrice of L. So the question could have its resistance is increased by 3 times. Increased by 3 times, it has different meaning, and increased to 3 times, both have different meanings. So here the sense is coming like increased to 3 times. This is 1 time, 2 time and 3 time. So obviously what remains constant, that is volume of the wire will remain constant, and here this is say the new length L dash. The area of cross section will be again what? Less. So the volume of the wire remains constant. Hopefully you must have got this. What is happening? On stretching the wire becomes thin but its length increases. This volume equal to what? Initial volume will be equal to final volume, that is A into L is equal to, suppose new area is A dash and new length is L dash. Agree? And we know, okay, from here say L dash upon L is equal to A over A dash. L dash is how much? 3 of L, this is initial length, and A over A dash, and this is equals to A over A dash is equal to 3. Fine. Now suppose the initial length was R, that will be equal to rho L over A. The new length will be what? New resistance will be equal to R dash is equal to, rho remains constant, no change, and the length becomes L dash and area becomes A dash. So what will be the new resistance? That we have to find. So R dash over R is equal to rho L dash over A dash divided by rho L over A. So rho cancels this. So this is giving you R over R dash is equal to L dash over A dash multiplied by A over L. So L dash over L is obviously, this can be written as, okay, L dash over L and A over A dash. So L dash over L is how much? 3, because the new length becoming 3 times of previous length. So this is equal to 3 into A over A dash. We had A over A dash is equals to 3. So this is 3. So R over R dash is equals to 3. Now, no, this is R dash, this is R dash, and this is R. This is R dash and this is R. So this is giving you R equals to, this is becoming 9. So R dash is equal to 9 times of R. And value of R is how much? That is 10 ohm. So 9 into 10 is equal to 90 ohm. Remember, this is very important. So new resistance R dash is equals to 90 ohm. This is one way of solving this sort of questions. The question is that the wire, whatever of resistance is, it's being stressed 2, thrice, 4 times, 5 times, 10 times, 100 times, whatever. So we are simply getting here, the new resistance is becoming what? 9. And 9 is obviously the square of 3. Square of 3. So we are going to have one more solution of this short. So this is first solution. This is obviously clear. Is it clear? Hopefully this must be clear, because we are what doing? Again, have a look, and the volume remains constant. That is area of cross section into length, new area of cross section into length. So this is giving L dash over L equal to this, and finally we are getting the previous area over the new area equals to 3 times. That is, the wire becomes thinner by 3 times. So R is given by rho L over A. So R dash equal to this. By simplification, we get R dash equal to 9 times of R. Agree? Another method to solve this question, that will be very simple, because you cannot do such a lengthy solution in examination period, because it will going to consume a lot more time. So simply focus on the question. The new length is stressed, or wire is stressed 3 times. So by what factor? By how many times the wire has been increased? So here N is equal to new length over old length, or the new length is equal to 3 times of initial length, and initially the length was this. So this is equals to how much? 3. So here you have to put a simple formula, that is new resistance R dash is equals to N square of the previous resistance or old resistance. This is the formula when we do such types of questions. See, wire is being its length is stressed to that many times. So this is what the number of times the wire has been stressed. So this is equal to N equal to what? 3 square, and what's the value of R? That is 10 ohm. So new resistance is equal to 9 equals to 90 ohm. So why to go for this longer method, rather we go for this very simple method. Now we shall see one more type of questions in which the question gives you by some percentage the length increases.